Good. All right. Yeah, okay. So yeah, once again, my name is Mehul. Let me just hide that. Um, yeah, so we're going over number representation, control, scoping, domain, and range. Um, yeah, so yeah, welcome to CS10. There's also a weekly last zero. So make sure you read that. Um, by the way, does anybody have any logistical questions at all or anything like that? Yeah. Okay. So Project Party is attendance is not required for Project Party, but it's highly recommended that you show up. I feel like okay, if you're there for 2 hours, you should be able to finish the project. We have about four tutors there, and yeah. Okay, so yeah, my name is, can I hide this? Uh that's okay. Yeah, so my name is Mehul. I'm a rising senior majoring in CS and data science. I'm from Hayward, California. It's a 30-minute drive south from here. You can just take the BART to get there pretty easily. So I took CS10 in spring 21, which okay, it's been maybe I think two years. Okay. And I was an AI, which is an academic intern. So they're the ones that help out in labs, assist students if they have any questions. And I've been here. Yeah, I was an AI for 2 semesters in spring 22 and summer 22. I was a reader. So readers are the ones that kind of like grade your projects. Like we used to have an essay project, but due to time constraints, we don't have the essay in the summer. And they're the ones that grade your final projects, which is what the essentially, it's like the one where you can create anything in a program of your choice, either Snap or Python, but more on that maybe in like week, maybe 5 or 6. Um, so yeah, right now I'm taking CS160, which is the user interface design and development. So I'm also in charge of like updating the website. So there's a bit of like UI design behind that. And yeah, so my interests are in artificial intelligence and web development. Um, yeah, outside of school, I'm an anime fan, and I like to play on the Nintendo Switch. Yeah. So, okay, before we go that, how about let me pause this? Can I pause the recording? All right, let's reconvene. For those walking in, is this recording? Make sure to grab a discussion worksheet in the front. So, yeah, I just got confirmation the discussion worksheets themselves, like what you write on, they're not being graded. So, yeah, as long as you stick around to the end, get the secret word, attendance form, you're basically get credit, right? So, okay, how about this? Like show of hands, one being like you're I guess like you've never seen this in your life, no representation, or maybe you're not that confident. Five being like oh yeah, you like if you had an exam question right now, you'd be ready to do that. So show of hands, 1 through 5. Yeah. Okay. So kind of mix. Okay. All right. Well, okay. So number representation. So essentially, like let's see, what do we have here? So I guess the one we're used to is the decimal system. So that's the number representation that we use every day. So for I guess yeah, just like for like our yeah, everything. But binary, that's kind of the language that um computers use. If you guys are walking in, make sure to grab a discussion worksheet in the front right now. Yeah. So yeah, I guess kind of like what Vedant showed you guys in lecture. Um, yeah, it looks like he converted the audio to binary and yeah, changed a few numbers around and changed the audio. But okay, yeah, but essentially like I guess like another way to think about this is like okay, like the high level code that we're writing in Snap, it gets like compiled. We translate that into maybe like a language like JavaScript. We further compress that down into like essentially zeros and ones. And so that's the lowest level of like abstraction you can get basically. And so okay, binary like there's a lot of zeros and ones, but to kind of make sense of them, we can group them together into hexadecimal, which is base 16. So binary is only zeros and ones. There's only two possible numbers in that world, right? So yeah, by two, right? Hexadecimal base 16, right? So we have for hexadecimal, we have like the numbers 0 through 9. And then we start with going off by letters because we're out of numbers. So A through F, right? Um, so in general, if we have a number system in base n, then the number in that system uh, starts from 0 or it goes from 0 to n minus 1, right? So base 10, 0 to 9. Maybe like base 20 would probably be like 0 to 9, A through F, and then what, G, H, I, J, K, something like that. Um, okay, so I guess knowledge check. If a number system is greater than base 10, how do we write numbers that are greater than 9? Yeah, yeah, letters. Okay. Um, yeah, so just keep going down A through Z. Actually, I don't know what happens when we get like past Z. That's maybe I don't know about that. Okay, so let's see. Yeah, I kind of went over this. The lowest level computers operate on zeros and ones. Okay, so an example of like the decimal system, right? So let's see, what is the time? 1:21. Okay. Um, so this is kind of like the ones place, the tens place, the hundreds place, right? That's okay. So the ones place to represent this five, well, five can be represented as 5 times 10 to the zero, right? Five. Okay, now how do we represent? Well, like we want to make up 245, which is composed of like kind of three different numbers, right? So for each like place or for each digit, we multiply it by like what, I guess what digit they are, starting from like 0 to n. Like so this is the five would be at place 0, the four at place 1, the two at place 2, right? Or like the power, right? So 245 is essentially 5 times 10 to the 0 plus 4 times 10 to the 1 plus 2 times 10 to the 2. Does that make sense? Thumbs up if that makes sense. Yeah. Okay. Okay, so now binary. Okay. So 0, 2, okay. Yeah, so essentially binary is represented in like in zeros and ones, right? And so I guess the way we would want like the way to convert this to base 10 is we would write out this binary representation. And so we multiply it by the digit that's right here and multiply it by two. Two is our base. There's only two kind of numbers in the binary world, right? And multiply that by zero because this is the zero places, the first place, second, third, fourth, right? So that's what's happening there. Multiply that by the number that's currently there. So 0 times 2 to the 0, 1 times 2 to the 1. And so the sum of all of this is 22, which is in base 10. And then we'll also go over how to convert decimal to binary in like maybe another slide. And so to convert hexadecimal to decimal, um, I think I'll try to see if we can post the slides after class or something, but I'll have to ask Eric because yeah, okay, so converting hexadecimal to decimal, right? So we have a 3 right here. Multiply that by 16 to the 0. 16 is our base, right? And then 0 multiplied by 16 to the 1. A basically we're going to translate A to 10, right? So for letters like if we had C, we're essentially translating C to 12, right? When we're converting from it's like any other base to decimal, right? We would essentially have to like translate it to the decimal equivalent when we're converting, right? Okay, so let me see how uh okay, how about this? I'm not gonna go over every single problem because discussion, like usually in discussions, we're not gonna cover the whole worksheet, right? So we're gonna cover like a few problems I think are important, and then you guys can try it out on your own for the other problems. And so right now, how about let's see. Yeah, maybe I'll just do one of these. So how about I give you guys based off of what you know. Am I in the Zoom room? Oh wait, I have to stop sharing. Share my other screen, my tablet. Uh, Okay, yeah, so we're basically gonna do question one. Um, we're gonna do this one right here. We're gonna do this one. So I want you guys to convert either binary to decimal or and like just essentially have practice converting the binary to the decimal and hexadecimal, and then you should get the same answer from both, right? So does everybody know what to do? So we're doing this problem, convert this to decimal. Don't worry about this one. I probably just won't get to that one. Yeah. So yeah, you can talk to the peers around you and we'll reconvene in maybe 4 minutes. So like 1:29. Or okay, we'll reconvene at 1:30. Got it? Maybe I'll leave this up. Yeah, so I'll just leave this example up. All right, I think I'm gonna go over now just so we have time for other questions as well. Let me just copy this over and see how I can do that. That's fine. I copy that. So I guess I'll do it but like two ways. So we're gonna convert binary. Can everybody see? Yeah. So binary to decimal, right? So this is what we have. Um, and so this is we're converting this. So there's a zero right here. So 0 times 10 to the 0, right? Or no, sorry, 2 to the 0, because this is in base 2, right? Plus 1 times 2 to the 1, uh, plus 0 times 2 to the 2, plus 1 times 2 to the 3. Uh, okay, so I got this part. Now this part is 0 times 2 to the 4, plus 1 times 2 to the 5. The rest are zeros. I think I'll just omit that. Well, yeah, this is let's see, 1 plus 2, 0 plus this is 8, 0, 32, right? So 40, 42, 44. Did people get that? 44. Thumbs up if you got that. Okay. So yeah, I guess I can also show while I'm at it, binary to hex, right? So there's a way to convert binary to hex like directly without going through decimal, right? So let me just rewrite this right here. Huh? Where's my error? Wait, that is this right or no? Yeah, oh wait. Oh, sorry. Yeah. Yeah. Okay. So what is the answer here? 42? Okay. All right, cool. Yeah, glad you guys caught that mistake. Yeah. All right, so right here, essentially to convert binary to hex, I guess I guess it's kind of similar right here with a bit similar with decimal. So uh so we have 8 and we have 10 right here. So uh essentially if we want to convert binary to hex, we have to uh group the like terms into 4, right? So right here, this is equal to 10, right? And hex, that's an A, right? And now for this part, this is 2 to the 1, which is 2. So that's how we got 0x2a. Does that make sense? Do people have questions? Binary to hex? Okay. Okay, let's see what else I have. I don't think I'll be able to go over more. I know the electric quiz went over this a lot, so okay. Maybe I'll just do one of them. Okay, so decimal to a different power. So let me see. We read okay. Uh oh, I see. He did decimal to binary. Okay. Um, I guess I'll just go over this through like an example. Okay, so I guess here. So oh, he did 20. Okay, so 20, if we want to convert 20 in base 10 to binary, so we draw out the chart, right? So um the 2 to the 5 is 32. Can we fit do we have like greater than 32 in our current number? Well, no, we don't. So we put a 0 here, right? Can 20 like can some of our 20 fit into 16? Well, yeah, right. So we have greater than 16 right here. So we're gonna put a 1 here, cross that out. Now we have a 4 left. Can we fit 4 into 8? Well, no, we that the 4 is less than 8. So we put a 0 here. 2 to the 2, which is 4. Well, that fits into like the 4 column right here. And the rest we can just put as zeros, right? Uh, cool. Um, yeah, so that is basically this is a good chart to have. Should definitely put this on your cheat sheet when you're reviewing for the midterm. Um, yeah, I'm gonna go. Yeah, we're going to. All right, we're okay. I'm gonna do booleans now. So yeah, booleans. So essentially, booleans they're essentially like true or false values. And in lab, we can control which parts of our code execute through booleans using if and else statements, right? Um, yeah, if you haven't been to lab, actually, I think everybody here, yeah, most people here haven't been to lab. So yeah, that's what we're gonna be doing next, basically from 3 to 5. Okay, so yeah, so and blocks, they return true, if and only if both inputs are true. So for example, I might have two conditions, right? Uh, maybe Alonso, well, let's say Alonso wants to wear a jacket, right? He wears a jacket if two conditions are true, right? If it's raining and if the temperature is greater than 60, right? Uh, and so if both of those conditions are true, then Alonso will wear a jacket. That's one example, right? But if one of the conditions is false, uh, then he won't wear a jacket, right? So return true is if at least one input is true, right? Uh, yeah, let me. And so not returns the opposite of what the input is. So if like rating is true, we input the boolean or like the variable rating into not, then not rating would be false, right? So not true is false, not false is true, basically, right? And so this whole kind of like and block can be extended into like n different variables, right? There's not really a limit, right? And so this can get a bit tedious to calculate if we have like so many different variables and like different like conditions to check, right? And so yeah, the naive approach is to check every single see if every single statement is satisfied, right? But there's this thing called short circuiting, right? And so if we see one false value in the and statement, like in and, if one value evaluates to false, like okay, let's say this is true, this is true, this is false, right? There's no way or like and returns true if everything is true, right? So if we see one false, there's no reason for us to keep going, right? So we immediately report false when we see the first false value. So that's short circuiting. It's like, I guess it's called lazy evaluation. You don't have to evaluate everything if you don't need to, right? We need to, yeah. So, or like, I guess the or block is, so and is basically the false finder. You can think of it as the false finder. If we see one false value, we're done. Otherwise, we keep going. If we keep seeing true values, keep going until we see a false value. If the last value is true, then the whole statement is true, right? So for or, the or block, um, it's like opposites, and or they're opposites, right? So yeah, does that make sense? I don't know if I'm like if I should be lecturing like this much because okay. But yeah, I guess we can go over let's go, yeah, the truth table, that one is next actually. That's okay, so let's do problem two for about 2 minutes and then I'll go over it, which is this one. Yeah, so just take 2 minutes to go over that. All right, does anybody have any ideas for the first one for height? So the question is, you're at Six Flags, and to go on a ride, you need to make sure that your height has to be over 50 inches tall. So does anybody have ideas like what goes in this in the reporter block? Any ideas? Some kind of condition, yeah. Oh, so you basically did like not height less than 50, right? Okay. This is valid. Equivalently, height greater or wait, uh height greater than 50, right? So reports true if you can write go on the right, I think, right? So this is like the negation, right? So cool. I'll go over this one. So let's see. So we're at a football team and we want to see if we qualify for the second round. So we need to have a mile time. So our mile time needs to be 7 minutes or less. So we can do less than or equal to. Um, and yeah, 7. So that's the first condition. Or have a height. So I guess or have a height above 72. So height greater than 72. Does that make sense? Okay, so now in Snap, I guess for the and block, this would be a kind of our first or maybe I could, well, that would take a bit longer. Um in Snap, this would be our first input to my and block, right? This whole condition right here. And my second input would be since we need an and, right? So these two this is basically my first parameter to like the block, right? So these two will evaluate to one single expression, either true or false, right? So we check we also need a bench press. Uh I think, let's see. Yeah, it just says 170 pet. Yeah. Oh, yeah, yeah, actually, yeah. Okay, thanks for that catch. Yeah, it looks like that. So let's see. Or okay, yeah, okay. Height above 72. Okay. Yeah, so so just to recap, um, so the mile time, so this is we're using an OR block right here, which is separated by a comma. So this is the first and this is the second condition, right? So the mile time is less than or equal to 7, or the height is greater than 72, and the bench press, I guess, equals 170. That's yeah, it doesn't say like less than or greater than. Yeah, does that make sense? Do people have questions on that? Yeah, thumbs up. Yeah, okay. Cool. So 141. Let's see what else I got. Okay, so this truth table, I'll just go over this one. Um, okay, so truth table. So, essentially, we have two variables that can take in two possible values. So the different possible combinations kind of look like this, right? So either both of them are true, one of them is true and the other is false, or both of them are false, right? So A and B can represent any kinds of variables, right? Whatever you want. Like this can be like a condition like raining or weather or something like that, right? Just any kind of true or false. So these are either true or false, right? Okay. So the thing about and is they report true if and only if both conditions are true, right? Otherwise false, right? So that's what the truth table looks like for that. Um, and you'll also see this in the lab too. So for or, they report true if at least one of the conditions is true, right? So otherwise, if both inputs are false, then we report false, right? So that's what this looks like. And so now we have like kind of like this nested expression right here. So I'll give you guys maybe 2 minutes to think about this and then we'll reconvene how to do the other one. All right, I'm gonna go over it this one now. So we have uh we have an OR block with I guess two different inputs, right? And so we first start with A and B, right? The first row, A and B are both true, right? So this reports true, right? So the thing about OR is that if we find one truthy value, we're done, right? Just report true, right? So we don't need to check the other part. right? We don't need to check what that does, right? So, okay, now for this part, for every other block, this is gonna report false because like every other row, they're never both true again, right? So now we have to just check the second part, right? The second block, right? And so both of these, so we have not A and not B, right? So the thing about not A and not B is so hold up, yeah, not so and reports false if both, or sorry, and reports true if both inputs are true, right? So the only way for this to kind of happen is like, okay, say like A is false, B is false, right? And so not A is true, not B equals true. So when A and B are false, right? This is the only time when uh this is true. Like the like or block reports true for this part of the expression, right? Otherwise, it's going to be false, right? So does that make sense? Right? Yeah. Okay. Yeah. So Vedanchi asked a similar question in the summer midterm. So I would recommend going over this, kind of reviewing this. And when you're studying for the final, these are my lab slides, but uh maybe go over this block as well. It's kind of similar. Um, yeah. Okay, so uh wait, did I have more slides? Oh, he just put, oh, okay. Okay, I see. Yeah, yeah, okay. So that's the answer. Okay, so yeah, let's do we're at 147. I'm gonna skip to uh the other question, domain and range, because that one is a bit important as well. So yeah, so domain and range. So domain is basically the inputs to the function. What can this function take in? The range is the output, right? Um, so what kind of what data type can I guess here, let's maybe I can give, oh wait, he actually has something for this. Okay. So for example, the number, um, so you can kind of represent what you can kind of see what data types, what the domain and range are in Snap based off of like the shape of like the block, right? So a circle kind of means like, okay, this takes in a number, right? And kind of like this like other circular shape on the outside means that the range is a number, right? I believe so, or maybe I think it's just text because right here, this is going to be text as well. So the data type, if you see something like this, kind of like a box, it takes in text, right? Boolean is hexagonal, right? So the input to this is a Boolean, true or false. The output is a Boolean. List, kind of like this, two lines. Uh, yeah. So yeah, this is a number right here. So this takes in a function, or this is kind of like we'll go over this, I think, either in today's lecture or Monday's lecture, like taking in functions as inputs. So you don't need to worry about that one so much. But yeah, so the domain is based off of the inner shape, and the range is what the outer shape of the block is. Does that make sense? Yes. Okay, let's do this problem for like maybe 2-ish minutes, and then we'll reconvene. Right, thumbs up if you're ready to go over it. Thumbs down if not. Thumbs up. Okay, so all right. Does anybody have any ideas for part A? What the domain is for that? Okay, yeah, part A, domain. What are the possible inputs, right? So what I guess this shape, what does it tell us? Like I guess maybe you guys probably yeah. Yeah, we kind of haven't gone over lists yet, right? So that's fair, right? So this one, so this is a list, or I guess we barely introduced lists, right? So this is a list. So this contains block checks if maybe we have like hello uh sandwich, right? Maybe that's our list, right? And so this block checks if like maybe I can input this list, right? And I can ask, does this list contain hello? Reports either true or false, right? So this is a hexagonal shape. This means it's a Boolean, right? So the range is a Boolean. So true or false, right? Domain, this is a list, right? List is gonna look like ladders. I think that's what it looks like to me. Um, and so this kind of square shape is like text. Yeah. Thumbs up if that makes sense. Yeah. Thumbs up. Okay. Okay, so this is asking what the domain of foo is, right? So domain is like the inner shape, right? And so who thinks this is text? Raise your hand. Who thinks this is the domain's a Boolean? Number. Okay, it's a number, yeah. Okay, so the range of foo is as a Boolean as well. True, false. And so the data type of the variable is actually a function, right? We're setting variable to the function named foo, right? So data type is a function, right? Okay. Cool. So yeah, I don't huh. Let's see, what is the time? 1:53. I guess I'll do okay. I'm just gonna go over this since we haven't actually gone over scoping in lecture yet. Actually, yeah, there are slides for this. Uh wait, actually, okay. Um Dang it. Okay, yeah, that's what I said, yeah. Oh, data type is a Boolean. Oh yeah, actually, yeah, so yeah, sorry, my apologies. So the data type, we're going to call foo on an input, right? And so that input is gonna return us, report us a Boolean true or false. So variable will actually be a Boolean. So yeah, essentially we evaluate the expression fully and we output the Boolean either true or false. Okay, so scoping. So there's two different variables in Snap. There's the global variable and the script variable. So global variable, any sprites can use it anywhere in our code, right? The script variable, it only exists within that box code, right? And so in terms of scoping, how do we know what variable to use? We might have two variables with the same name, right? Maybe in the global scope, and we might have a variable the same name in like the script variable or the local scope, right? So the kind of the flow chart of when to use what is like script variable is kind of like your block code, right? If you're within like a block code and you're executing code, if you have two variables of yeah, take a picture of this. This is kind of I would say this is important on the midterm, or just refer back to the slides. So we first see does this script variable exist in my scope? If it does, use the script variable. If it doesn't, go on the higher level, which is the like the global frame, right? The global scope. Does it exist there? If it does, use the global variable, right? If it doesn't, that means the variable isn't defined anywhere. We throw an error, right? So okay. What? Okay. Uh well, I'm just gonna walk through this anyway, right? Um okay, how do I screen share? All right, stop that. Okay, so yes. Okay, so we have this script right here, right? So we have my age. So right now, let's say we're performing this line of code, right? Where the arrow is. So that by default, snap, if you haven't like declared anything, my age is set to 0, right? Now we get to this line of code, right? Now we set my age to 19. So the now this is set to 19. We go into here, essentially we're calling the block, or we're calling this command block. So we go in, so this is like the global sorry, the let me move this. So this is maybe like the local scope, right? Local scope, right? And so now we're going to open up a frame. I'm going to call this frame one, or happy, or have birthday, right? Have birthday. So we're passing in this a variable called my age, right? So we're passing in my age, which is set to 19, right? And right here, we're going to perform this line of code. Or sorry, the variable name is actually called age when we get into the function, or like the block right here, right? And we're going to set age to age plus 1 right here, right? And so we're just going to override this to 20. And so the thing is, even though we set my age here, uh, we only modify age in frame 1. It doesn't affect the outer frame. It only affects the outer frame if it's a global variable, right? Since this is a local variable, like it was defined here and not globally, um, we yeah, that we don't update it here. We only update it in the block level of the code, or like frame 1, right? So when we exit out of this code, like when we finish the function, right? Or we finish the block. So essentially we erase this, right? This no longer exists. We go to this line of code and we say my age. And my age is 19, right? The this one, it just disappears, right? If we wanted to kind of like actually change the value of this, maybe I'll show you how to do that in lab. But you would have to like use the set block, set my age to have birthday my age. Except this is a command block. So instead we would have to actually use a reporter block if we would want to do that. So yeah, so the value that is printed out is 19, right? And yeah, I guess I'll just keep going until Vedansh gets here. Since yeah, the lecture's in the same room here. Um, okay, so how about this? Does this do the same thing? Oh, I see. Okay, so the difference here is that age is not defined in this scope. It so when we exit, like when we go back to this line of code, we exit out of the function, right? We erase this. Like it no longer exists in our memory, right? So this would actually error out because age is not defined in the local scope, right? Does that make sense? Thumbs up. Okay. Um, yeah. Okay. I guess I'll go over this last one. Then I'll hand over to Vedansh. So, part C, we have like our local frame, right? We have the variable my age. We set it to 19, right? And so now we're going to execute this block of code. We're going to pass it, we're going to go into have birthday, right? and we're passing in the variable age, which has the value 19, right? Um, yeah, and so now we're going to set age to my age plus one. So we read the value of my age, or actually wait, no, actually no. So the thing about this, so this is actually a script variable, right? So this script variable is only defined in this piece of code, right? It's not a global variable, so there's no way for us to access it in this block of code when we're executing this. So when we're in this level, we're going to see does there exist a variable called my age inside of my frame one, right? No, there doesn't exist a variable called my age. It's kind of going back to like this chart right here, right? And so now we're going to check, is there a global variable called my age? Well, no, there's not a global variable called that. So we're actually going to error out. Yeah, does that make sense? Does anybody have any last minute questions? Yeah, or what?
Can you go back to the
Okay.
so my age is only accessible in those 4 blocks like that under the script variable my age.
Yeah, so yeah, my age is only you can only have access to my age inside of this script right here because it's a script variable. If it was a global variable, then we can access it anywhere in Snap. Yeah.
Since you're saying my age, nothing's changing my age, wouldn't it at 19?
Oh no. So on this line of code, like we open up this block of code, we try to set age to my age plus one, but it'll error out when we try to read in the value of my age. Because first we look in this frame right here, but we see it's not defined. We look in the global frame, it's not defined. So the block will never go to this line of code. If we run into an error, the script will just stop completely. Does that make sense? Cool. Well, okay, I'm gonna stop the recording then and hand it over.